Exercise, okay. Example exercise 11.1, rotational coordinates. So let's look at how we can apply it and how we can calculate it. Okay, so it says determine the rotational coordinate. Remember that thing looks like this, which is actually a lowercase theta. That's it there. Determine the rotational coordinate of the following objects for the indicated choices of rotational coordinate system. Okay, so remember, again, you need a place where this is 0. Okay, we'll see what that means. And whether it is clockwise or counterclockwise. Okay? All right, so it says, determine the rotational coordinate. I'll get there. For this, the tip of an hour hand of a clock at 4:30 p.m. when 0 is at noon on the same day and theta increases in the clockwise direction. Okay, so it took me quite a while to absorb this information. Maybe you'll get it in a split second. Okay, so let's have a look at a clock. Okay, just imagine, use your imagination that's a circle. Okay, that's 12, that's 3, that's 6, 9, okay? And then that's 1, 2, 3, 4, 5. Okay, so the hour hand starts there at noon. Okay, the 0 is at noon, so that's the origin, and it increases in the clockwise direction. So we want to do this. There's the dot. We want to do this. Actually, that's not right. It should be. It should start. It should start like that. And then there is my, so there's the dot. It starts at the 0, which is the 12, and it increases clockwise. It increases clockwise. Okay, so that's the beginning one. It starts at 0, and then it moves to 4:30. So it says when the hour hand is at 4:30. So remember, 4:30, the hour hand is going to be in between 4 and 5. So the hour hand would have moved to there, to 4:30. So it starts at 12, so it moves to 4:30. So that is the rotational coordinate we're after, is this. Okay, so what do we do? Well, we know that if you measure this in degrees, then that is 90 degrees, and each one of these guys, that guy and that guy and that guy, is 30 degrees. You can just work it out. So if you take 90 divided by 3, you get 30. So each of these is 30 degrees. Okay? So this angle over here is 90 degrees plus 30 plus half of 30. So that entire angle is 135 degrees. But what percentage is this of an entire revolution? An entire revolution is 360 degrees. So it is, so if we divide by 360 degrees, we will get this 0.375. 0.375. So this is 0.375 of a revolution, okay? But the way that we calculate our rotational coordinate is we multiply now 2 pi, which is an entire revolution, okay, by this percentage of a revolution. I guess it's not you have to multiply by 100 to get a percentage. And this is what we get there. Plus 2.36. The plus is because it moved in the positive direction. and 2.36 is now the value of our radial coordinate. Okay, so now what about B? B says a faucet, which is a tap, after being turned 3/4 of a turn in the clockwise direction, starting from 0, and with the rotational coordinate increasing in the counterclockwise. Okay, so let's look at B. So let's just draw it. I mean, if there's your tap, okay, so it says that the rotational coordinate increases in the counterclockwise. So I guess we can start anywhere. It doesn't give us a specific place where it starts, but it looks like that. And then we draw our coordinate over there. Okay, so just going to draw that again, like that. So there's your theta. So it's going counterclockwise as positive, but it turns clockwise. This guy turns 3/4 clockwise, 3/4 clockwise. So if positive is counterclockwise and it turns clockwise, then it turns -3/4 of a full revolution, and we multiply that by 2 pi to get it into its rotational coordinate. So its rotational coordinate then is -3/2 pi. Okay. Now what about C? C says the object in figure 11.4, if theta equals 78.3 degrees, when 0 is at theta equals 0 degrees. So if I'm not mistaken, it looks something like this. There's your theta equals 0, and then it goes to there, and that is your theta is 78.3 degrees. Now again, how do we convert to rotational coordinates? We see what percentage of this, percentage is maybe not the right word, but we divide this by a full revolution. So we say 78.3 divided by 360. Okay, I don't actually know what that is. But hold on. It says the rotational coordinate increases in the counterclockwise. Okay, so this moves in this direction, and that is the direction of theta. So this has to be plus. So you first get that ratio, and then you multiply by the 2 pi, and we get plus 1.37. So in the rotational coordinate, this is 1.37 plus. Okay? All right, hope that's helping.